Fireproof balloon experiment. Balloons are fragile in nature, so they must be kept away from sharp objects. They also need to be kept away from flames. A fire can weaken the rubber and cause it to burst. However, in this experiment, you will find out how you can hold the balloon directly on a flame without breaking the balloon. For this experiment, you will need 2 round balloons, several matches, water. Procedure. First, inflate one of the balloons and tie up its mouth. Place 60 milliliters, that's quarter cup of water, in the other balloon and then inflate it and tie it shut. Light a match and hold it under the first balloon. Allow the flame to touch the balloon. What happens? The balloon breaks, perhaps even before the flame touches it. Light another match. Hold it directly under the water in the second balloon. Allow the flame to touch the balloon. What happens with the balloon? The balloon doesn't break. You can see a black patch of soot form on the outside of the balloon above the flame. What happens? To understand this experiment, 2 questions need to be answered. The first one is, why does the balloon with no water break in the flame? The flame heats whatever is placed in it. It heats the rubber of both balloons. The rubber of the balloon without water becomes so hot that it becomes too weak to resist the pressure of the air inside the balloon, so the balloon breaks. How does the balloon with water in it resist breaking in the flame? When water inside the balloon is placed in the flame, the water absorbs most of the heat from the flame. Then, the rubber of the balloon does not become very hot. Because the rubber does not become hot, it does not weaken and the balloon does not break. Water is a particularly good absorber of heat. It takes a lot of heat to change the temperature of water. It takes 10 times as much heat to raise the temperature of 1 gram of water by 1 degree centigrade than it does to raise the temperature of 1 gram of iron by the same amount. This is why it takes so long to bring a tea kettle of water to the boil. On the other hand, when water cools, it releases a great deal of heat. This is why areas near oceans or other large bodies of water do not get as cold in winter as areas in the same latitude further inland.